Hey everyone, continuing from the last video and with quadratic equations, we're looking at equations where we can't factorize it nor use the quadratic formula. So what can we do? And the answer is to use the method of completing the square. Alright, so what does the completing the square do? So the idea of completing the square is at the end, you convert your whatever quadratic equation you have into these two forms, either x plus h square plus k, which is basically k plus x plus h whole thing square, or k minus x plus h square. Alright, I mean, of course, it can be minus x plus h square plus k. It's the same thing. Why? Very simple. By expressing the quadratic equation in these forms, you get the turning point, which is simply at minus hk, whatever the value of k is, whatever the value of h is. Alright, so if let's say h is minus 1 and k is 1, you'll get minus 1, which is 1, comma 1. Alright, I'll show some examples later, don't worry about it. Why is that so? Why do you have a turning point at minus h, comma k? We go back to the idea of squares, right? So let's say we have x squared. We know that x squared must be positive or 0, aka non-negative. Alright, because two numbers multiplied together, positive numbers multiplied together would be a positive number. Two negative numbers multiplied by each other would result in a positive number. Of course, if 0 multiplied by 0, it will be 0. And we know that x squared is bigger than or equal to 0. And by extension, x plus h, if you square this, is also bigger than or equal to 0, whatever the value of x plus h is. And this only, and you notice that because it is bigger than or equal to 0, the minimum value is at 0. And this occurs at x equals to minus h. Now, we look at the other case where it's now looking at minus x squared. Because x squared is bigger than or equal to 0, minus x squared would then be less than or equal to 0. And by extension, minus x plus h whole thing square is less than or equal to 0. And that means the minimum value is no longer minimum value actually, it's now the maximum value, right? Because every other number is less than 0. So the maximum value is at 0 and it again occurs at x equals to minus h. And what this does is that now if you add the constant k, we get x plus h square big plus k bigger than k. We just simply add k on both sides. Alright, k minus x plus h whole thing square less than or equals to k. Alright, so this method works for whether or not you have real roots or not. Alright, so it could be, you could have used the quadratic formula, you could use factorizations, you could also be using the completing the square. On the other hand, if you do not have if you do not have factorization, if you don't have a quadratic formula, then it is recommended that you use completing the square. And it's very useful, especially for those in H2 and even in A math, for you to find the inverse function. Alright, I'm not too sure if A math does it. I'm going to check again. Alright, so let's have a few examples. Alright, so let's say we have y equals to x squared plus 2x plus 2. Alright, and how completing the square works is that because you're achieving the form of x plus h whole thing square, so as we know that x plus h whole thing square is simply x squared plus 2hx plus h squared, where h squared we know is a constant, so we can ignore that. And the focus is always on the coefficient of x, right? Because x is always x, then the idea is the coefficient is now 2h. So a coefficient is now 2, now we divide by 2. Therefore, x plus 1 squared. We know that 1 squared equals to 1, so we need another 1, so plus 1. And for this graph, the turning point is at minus 1, 1, right? Because x plus 1 squared, minimum value is 0 and x equals to 1. So we have x equals to minus 1, then y equals to 1. So the turning point occurs at this point. So we're going to draw the graph this way. Alright, something like that. Y equals to x squared plus 2x plus 2. Turning point is at minus 1, 1. Now at x equals to 0, we have y equals to 2, right? 0 squared plus 0 would be 2. Let's take a look at another example. So let's say we have y equals to minus x squared plus 2x minus 3, let's say. Right, again, we're now going to achieve the form of k minus x plus h squared, right? So minus x. Once again, look at the coefficient of x, right? Again, divided by 2. However, you must now take note that because we factorize out minus, we then need to also factorize out minus from 2x and minus 3 correspondingly. So we have 2x, right? Now, after factorizing out, we have minus x squared minus 2x plus 3. Alright, so take note of that. The coefficient of x in the completing the square form is minus 2, and you need to divide that by 2 to give you minus 1, and then whole thing squared. Alright, now very simple. If you look at the constant, minus 1 squared would be 1. But because of this negative, it will be negative 1. You have negative 3. So you need to add a negative 2 in front to give you minus 2 minus x minus 1 squared. Turning point minus hk minus h minus minus 1 is at x equals to 1. K is simply minus 2, so we just randomly give a minus 2. Your turning point will occur around here. Because it is a negative coefficient of x squared, it is a n-shaped graph, and therefore your graph will look something like this. Again, label your turning points 1, minus 2. Y-intercept at x equals 0 is simply negative 3. Alright, so that is the completing the square for your quadratic graph. Again, take note of the coefficient of x when you complete the square. In fact, that's a technique and a trick used. And also the coefficient of x squared to determine what shape. Is it a U or an N shape?